Okay, good morning, everybody. So let's go ahead, get started. So please repeat the question again. So it's, as a healthcare provider, how much you pay every year?
$6,000 per year is 40%.
You pay $6,000 per year premium. Is that what it is?
Oh, the insurance premium?
Yeah, it's 10,000, I believe, right? Isn't it?
It says 12,000.
Oh, 12,000. Okay. So you pay $12,000 per year for your health insurance. Okay. And then there is a 60% chance that a person would get sick, right?
Mm-hmm.
And once the person gets sick, how much the insurance company provides?
$6,000.
6,000. Great. Perfect. Thank you. So here is the problem. You purchase a health insurance. How much you pay? You pay $12,000 for the year. Okay. Now, this is a random person, some ordinary person, or everybody has to pay 12,000, of course, right? Then if an individual gets sick, the insurance is going to provide for the care, which is going to cost $6,000. And the chances of someone getting sick is about 60%. So as an insurance buyer, what is your expected return? As an insurance buyer, what is your expected return? So let's go ahead and talk about this problem. So there are a couple of events happening. One event is that you are paying $12,000. Okay. Another event is that you're getting $6,000. So X is the random event. Okay. A random value here. Random variable rather. So P of X. Okay. And admit. Okay. X times P of X. So there are two things that could happen. At the end of the year, what could happen? You're paying $12,000, right? So that's negative $12,000 for you. That's one scenario. The other scenario is that hopefully that doesn't happen. You get sick and you get $6,000. Okay. So these are the two things that could happen. What are the chances that you get sick? What are the chances that you get sick? 60% chance or 0.6. If you have 60% chance of getting sick, what percent chance you have not getting sick? What would that be?
0.4.
Huh? What is it?
0.4.
0.4 exactly, or 40%. Thank you. You have 60% chance of getting sick, 40% chance of not getting sick. Now, if you get sick, the insurance pays for your hospital bills $6,000. On the other hand, if you do not get sick, you lose your entire $12,000. Is the setup okay with everybody? Are you following the setup?
Yes.
Yes.
Okay, good. Now we are going to find the X times P of X. X is the random event or random variable. So it's going to be negative. This is going to be negative 4,800, I think. 100. And this is going to be negative positive 3,600. Okay, so let me double check. 0.4 times 12,000 is negative 4, yeah, so 4,800, and then 0.6 times 6,000 which is 3,600. Now, this column is gonna be your sum of this column is gonna be your expected value. E of x is equal to sum of x times P of x, which is negative $4,800 plus $3,600 is negative $1,200. So your expected return is negative $1,200. So as an insurance buyer, you can expect to lose about $1,200 per year. That's the expected return for you as an insurance buyer. But you're buying insurance from somebody else, right? Insurance provider or insurance seller, that is positive for them. It is negative for you, but positive for insurance service provider or insurance seller. So that's how they make money. Now look, you're paying $12,000, right? Probably your employer pays part of it, you pay a part of it. Most of the times your employer is gonna pay most of it. You're gonna pay a little bit of it, okay? Now look, the insurance company is getting their $12,000 regardless who pays for it, all right? But that means it is negative for you. On the other hand, it's positive for the insurance seller or insurance provider. So now you pay $12,000. If you don't get sick, you don't get a single dollar back, right? The chances of you getting sick is 40%. So you multiply negative 12,000 by 40%, that's going to give you 4,800. On the other hand, if you do get sick, which has a 60% chance, you will get on the average $6,000 bill from the insurance provider. So there is positive cash flow to you. So you think of it in terms of cash flow, that would help you. If you think of it in terms of cash flow, what's gonna happen, you would think, oh, $12,000 going out of my pocket, which is negative. $6,000 they're giving to me in terms of hospital bills. So that's positive to you. And the chances of that happening is 60%. So multiply 6,000 by 60%, that gives you 3,600. If you add these two numbers, you get negative 1,200. That means on the average, an insurance buyer could expect to lose $1,200. Negative, this number is negative, meaning it's losing situation for you. That means on the average, $1,200 going out of your pocket. If it is going out of your pocket, whose pocket is it going to? The insurance company. That's what it is. That's how you should be thinking about this problem. Is it okay, everybody?
Yes, thank you.
Okay, good. Any other question that I could answer for you before I move on to the topics for the class for the day? Anybody has any other questions? There was another student who sent me a couple of questions about expected value. I kind of forgot what those questions are. I'll go ahead and address those individually to the student. I kind of wanted to address it here in the class so that people can remember. Now, actually, I kind of remember the problems. So let me go ahead and address those. I created a little bit of confusion by introducing an additional condition. And I'm going to clarify it, and I'm going to ask you to just, for the sake of avoiding confusion, just follow this. So if you play roulette, what happens? Roulette has 38 numbers, 1 through 36, 0 and 0, 0. 1 through 36, 36 of them, then 0 and 0, 0. Now, what happens is this. Let's say you bet on the number 5. If the 5 shows up, okay, let's say you bet $1 on the number 5, okay? $1 on the number 5. If 5 does show up when they roll it, okay? If 5 shows up, your return is 35 times. That means you're gonna get $35. If 5 shows up, your return is 35 times, let's say. Okay, I don't remember exactly what the return was, but let's say it's 35 times. So then what is going to happen? Your events are gonna be this. X is the event, P of X is the probability that that event will happen, then X times P of X. So there are a couple of things that could happen here. One is they roll it, okay, or turn it rather, okay, and 5 does not show up. 5 does not show up. In that case, what happens to the dollar that you bet? You lose it. On the other hand, okay, if they turn it and 5 does show up, in that case, you get $35. So that means you get $35. Now, the confusion, so let me clarify here, emphasize here, the confusion came from the fact that when you get $35, you actually get 34, not 35. In reality, you get $34 because the turn for which you won, you actually had to pay $1 to play it, right? You did pay $1 to play it. So even though you got $35, you have to subtract $1. So your net return is gonna be $34. That's what it is. So I tried to clarify, but in the answer, in the problem set, I did not take that into consideration. I just put 35. So go ahead and ignore this, even though this is probably more accurate. So just do 35. That way you'll get the answer correct. I don't want to change the answer, honestly. I'll just leave it as it is for now. If I do need to change it, I'll change it later, okay? And it's not gonna impact your score at all. Because this created a little bit of problem. A couple of students were emailing me about this thing. So even though this is the more logical way of thinking, but in reality, I have done the problem in the homework like this. So now let me go ahead and do this. What's going to happen? So think, you lose $1, you lose $1. The chances of you losing the dollar is going to be 37 out of 38. Why is that the case? Because only way you will win is when 5 shows up, because you bet on the number 5. You bet on the number 5, right? That's the only way you will win. Now, your chances of losing would be when 5 doesn't show up. That could happen in 37 different ways, because 1 through 36 numbers, 0 and 0, 0, 38. So it is 37 out of 38. That's your chances of losing. Because if you take away the 5, there are 37 numbers left, right? It's 37 out of 38. So if you multiply it out, it's going to be negative 37 over 38. On the other hand, your chances of winning would be 1, because 1 out of 38, because only time you will win is when 5 shows up. So it's 1 out of 38. 35 times 1 out of 38 is 35 over 38. If you add this number, that is going to be your expected return, or summation x times p of x. Now, if you add it, it's going to be negative 37 plus 35 over 38, which is negative 2 over 38, which is negative 1 over 19, which is approximately 5 cents. is, let's see, what is 1/19? 0.0526. Approximately 5 cents. And that is what you are expected to lose. And once again, Maijin, I think you just joined. You asked me this question. So the confusion, I am guessing, came from the fact that when you win, you really don't get $35, you get $34. Even though the problem says when you win, you get $35, but to play that turn, in the turn when you win, in the play where you win, you still have to pay $1, right? You still have to pay $1, which means you technically are getting $34, not $35. But in the homework, I actually use this 35 as opposed to 34. So there is a slightly technical mistake there, but I have not changed it. However, I mentioned it in the class, and that has created a bit of confusion. So don't use the 34, use 35. In the future, right for now, since the homework has already started, I'm not gonna change it. For the future, sometimes in the future, I might change it. However, it will not impact your grade, okay?
So this is question 4. You're saying to use 35 and not 34, and that's where my numbers were skewed?
I believe so. I don't have it in front of me right now. That's why it was skewed, probably.
Okay, because what I came up with is I found your answers, and it looked like, because question 4 you gave 2 probabilities. It was number 5 and number 6 on the Russian roulette table. Or no, question 4, it was only one number that the person was betting on. And it looked to me that instead of 37 out of 38 on the probability, you put 36 out of 38, because that's the only way I could come up with the answer that you came up with. So my question was, why was it 36 out of 38 and not 37 out of 38 if they're only betting on one number?
It should be 37 out of 38. Where did you see? Did you get -1/19 as expected value?
My answer for number 4 was -3/19. And the answer that's in there, I don't remember. I think it was -2.
It should be -1/19, if I'm not mistaken.
Okay, well, I just think it just looked funny to me because I couldn't figure out how you got the answer, and I tried multiple ways.
Can you try this number right now, please, and see if it works? -1/19 or -0.05.
Okay. So that was what, 35,000, 7,000 standard deviation, and then it was, they bet $2, correct? I think.
Oh, did they bet $2?
Yeah, they bet $2 on one number.
Then instead of $1, if they bet $2, then it would be like this. So let's see. And is the return still $35?
On question 4, yes.
Okay, so let's go ahead and do it with $2. Okay, you either lose $2 or you win $35, right? So technically this should not be $35. It should be 35 minus 2, because to play that turn, to play that winning turn, you still have to pay $2. So this should have been technically $33. Okay. However, I did the problem with 35. That's what has created the confusion. Now,
so what I did there, I actually, because you bet $2, I took the $35 return, multiplied it by 2, then subtracted $2. Is that the same result? Does it not matter?
Okay, let me do the problem and see where you did it differently. I'm not quite following you 100%. So let's just go ahead and do the problem, and then let's see where you did differently. So -2, what are your chances of losing that $2? It's 37 out of 38, right? So it's gonna be negative 74 over 38. Negative 2 times 37 over 38 is negative 74 over 38. Now your chances of winning is going to be 1 out of 38. Okay. Is it still $35? The answer here? That sounds kind of interesting to me. Okay. Can you make?
I'm logging in right now. I'm going to go check.
Yeah. If you bet $2 on one number,
So the
let me,
is
yeah, go ahead.
betting $2 on
Mhm.
number 17 with a 35 times the return.
Well,
And then the
35
answer-
times the return. Okay. So there's
And
going to
then
be,
The
yeah. go
answer
ahead.
was negative 2/19.
Okay, so 35 times return, okay? So there's gonna be 2 times 35, 70, okay? So that's why now it makes a bit more sense. So there's not $35 return, but 35 times whatever you invested or played. Investment would be a wrong word to use in gambling. So 2 times 35 is 70. So there's gonna be 70.
So would I
Over.
minus 2 from the 70 though?
Technically, yes, but don't do it because I kind of created the problem that way. So I'll stick to it, but in the future, I will change it, okay?
Okay, thanks.
So your expected return is E of X is equal to summation X times P of X. If you add these two numbers, you're gonna get negative 74 plus 70 divided by 38, which is negative 4 over 38, that is negative 2 over 19, okay, which is approximately 10 cents or so.
Okay, that makes sense because I was using 68 instead of 70, and that's why my answer was different.
Yeah, it's approximately 0.1052, okay. Now,
Okay.
is this clear? Does this clarify your question that you emailed me about, Maijin?
It does for number 4, but I still don't understand number 5. I also had the same problem where my answer was different than.
Okay, so tell me what the number 5 is, but before that, anybody else has any question on this one? Anybody? Anything that is not clear that I could clarify for you? Any question, anybody?
No questions.
No questions? Okay, good. Okay, Maijin, please read the problem too.
So once again, it's a roulette problem, and the person is betting $3 on 2 consecutive numbers, 5 and 6. And the return is 17 times if either 5 and 6 shows up. The answer is negative 3/19 on the homework, which I came up with, I believe, negative 6/19 was my answer. So right there, why is it 2 out of 38 for the probability, wouldn't it be 36 over 38? Sorry, for the $34 that you got, it's $3 that they're betting. Wouldn't it be 17 times 3?
Professor, you're muted.
Oh, okay. So you didn't hear what I said. Sorry. All right. Maijin,
Yes,
is it $2 or $3? I thought I heard you say two.
sorry, I read it really fast. It was $3 they were betting.
Okay, so let me clarify it. So you didn't hear. What is the last thing you heard from me?
Nothing.
Nothing.
So
Okay,
we're just setting up the problem.
let me set it up again. So my Jin said you bet on 5 or 6. These are the two numbers you bet on, and you bet $3. Okay, and the return is 17 times. Okay, return is 17 times. So now let's go ahead and write it down. X p of x, then x times p of x. Now, there are two things that could happen. You either lose $3 or you gain 17 times. 17 times 3 is 51, okay? So in theory, you should have subtracted $3 from $51. That should have given you $48, all right? But we are not going that route. I'll change it in the future. Again, I'm saying it multiple times to make sure that people don't get confused. Just do the problem with $51. Now, what are your chances of losing $3? Only way you could win is if 5 or 6 shows up. So that means 2 numbers gone from the list of 38, 1 through 36, 0 and 0, 0. So your chances of losing is going to be 36 out of 38. Now your chances of winning is going to be 2 out of 38. Why? Because you're betting on 2 numbers. Now, if you multiply it out, it's going to be 108 negative over 38. And then this is going to be 102 divided by 38. Now, if you add the values in the last column, that is going to be your expected return. E of x is equal to summation x times p of x. There's going to be negative 108 plus 102 divided by 38, which is going to be negative 6 over 38, which is negative 3 over 19. And that should be your answer.
Okay, thank you. I think the main issue I was coming up with the wrong answer is because I was subtracting the $2. So I used 68 for problem 4 and 48 for problem 5, and that's why I was coming out with a different answer. So instead of 51, I used 48.
In one of the previous lectures, I think not the last one, I think it's probably the one before the last lecture, I did actually do the problem that way. And I mentioned it as well that in the homework, it is done differently. So I should have really, that's my fault, guys, not you guys. I should have not created this confusion. I just should have changed it in the homework. Okay,
So in the future, it's going to be done this way that you just showed us.
In the future, I'm planning to change it. Okay, in the homework, and when I
okay.
change it, I will go ahead and let you know. Okay.
Okay, thank you.
Mhm. Any other question, anybody, before I start for the day?
Oh, Professor, I have a question again.
Yes.
Is it on number 6 again? Is my answer? Says I got it wrong.
What answer do you have?
Well, I pull up $1,200.
Huh?
I put 1,200.
Oh, did you put negative?
Yes, it says I got it wrong.
Did you give me the answers properly? I mean the numbers properly?
Yes, it says right here $6,000 per year is 40%, and then the insurance premium is $12,000.
Okay, I'll check it. Okay, I'll check it and get back to you. Can you email me from the problem, please?
Yes.
Okay. All right, anything else? Anybody? Okay, and also for that answer, make sure that one of the things, guys, this is a technical issue. If you are logged in into the system and you haven't done anything for a while, it logs you out. So sometimes this happens. So make sure that you log out and log back in. Okay. So whoever asked me this question, health insurance question, could you make sure that you log out and log back in and try to enter the answer, because that's what it should be. All right. But regardless, send me an email. I'll look at it. All right. So let's get back to our regular problem set. And I'm gonna just do several examples, by the way, with normal distribution, because it's important for you guys to be able to do it. I'm gonna spend pretty much most of the class today working on that. Okay. I'm gonna go ahead and do problems that cover different scenarios. And next week is spring break, so no classes next week. So the next time I'll be meeting you guys is, I think, March 29th, which is a Monday. All right. So let's do this simple example. Again, assuming that 1,500, 300, okay? In Dhaka, average income is mu is 1,500 and standard deviation sigma is 300. And in this problem, again, I'm kind of assuming we exclude extreme values, That means people, those who are too rich, we don't take them into consideration, basically. Those are extreme values. Then if there is the case, that we can go ahead and assume that it's bell-shaped. For some reason, I'm using income here, even though I told it multiple times. For income, we use median, not mean, okay? For income, we use median, not mean, because of extreme values. But when I somehow like this average income concept for ordinary people, okay? Middle class falls into the average. And also people who are in the lower strata of the society in terms of economic well-being, they also fall under the bell-shaped curve, except for the large people. I mean, not large people, people with large incomes. So anyway, our mean is 1500 and standard deviation is 300. And so let's create some of the scenarios. I want you to, everybody, please get the table ready in front of you. I will be asking, I'm not gonna get the table myself this time. I'll try not to. And I want you to find the following values. So let's say number one, we want to find the probability that someone makes more than $1,950. Okay, we'd like to find out that someone makes more than $1,950. That means a randomly selected person. So that means we are looking for this shaded region. Okay, this shaded region. Now we need to find that probability, we need to convert it into a standard normal distribution, remember? So what is the definition of standard normal distribution? What makes a distribution a standard normal distribution? Let's see, Edgar Martinez, would you tell me what makes a distribution a standard normal distribution? Okay, let's see. Leonardo Lomeli, what makes a normal distribution a standard normal distribution? Okay, anybody else? Looks like when when I start to ask question, people leave the meeting. That is that is not the solution to your problem. A couple of people, once I started to ask question, a couple of people left the meeting, and I can see it. That's funny. So anybody, what makes a normal distribution a standard normal distribution? This is basic. You must know this. Otherwise, you can't do these problems. So somebody be proactive.
Is it when everything to the left of the mu and to the right of the mu are mirror images?
No, that is a property of any normal distribution. Left and right is a mirror image of each other. What makes a normal distribution a standard normal distribution? What properties does it have? Jerry, what is it?
Well, what I have written down is, let me look at so the, it's made into it when it's 0 mu, and then the, what's it called? What's that? The sigma, I think, is that what it's called? Is 1.
Yes, exactly. So this should be something that should come to your mind instantaneously. Whenever we talk about standard normal distribution, you should be thinking right away. We are talking about mu 0, standard deviation 1. So please keep that in mind. When we are talking about standard normal distribution, we should be thinking about mu 0 and standard deviation 1. Okay. All right. So we need to go between these two. How do I go between any normal distribution and standard normal distribution?
Is
Okay,
that the formula Z equals X minus mu over sigma?
exactly. Z is equal to X minus mu over sigma. And these things, by the way, this is a critical time in the class. You need to do a lot of work. These things take a little bit of time to sink in. This formula should be a second nature to you. And standard normal distribution should be a second nature to you. Basically, whenever you hear standard normal distribution, you should be thinking mu 0, sigma 1, and Z formula. Okay, Z scores formula. You can do this. Now, let's go ahead and do this. We are gonna convert this point into a corresponding point here, which is gonna be Z, okay? And we are gonna find this area from the standard normal distribution table, and we need to find that Z value. And that Z value is easy to find. Z is equal to X is the number in question, which is 1950, minus mu, which is 1500, divided by sigma, which is 300. If you do the math, it's gonna be 450 over 300, which is gonna give you Z is equal to 1.5. So this is gonna be 1.5. Probability that X is greater than 1950 is the same as the probability that Z is greater than 1.5. So this 1950 maps to or translates to Z is equal to 1.5. Now, this is where I'm going to ask questions again. How do I find the Z probability of Z greater than 1.5? I need help.
Is it going to be negative 1.5?
It's positive 1.5. Positive 1.5. So anybody wants to, because I have done plenty of examples of this, because I think it's very, very important that you understand it. And I did this, but I could go ahead and do it again, but unless you proactively try, you're not gonna learn. Okay, I want you to try.
So is it positive 1.5 because it's the right of mu? On the chart, you would go look
Yeah,
up.
0. So on the chart, you should be looking, there are negative Z scores and positive Z scores. So this is a positive value, right? Z 1.5. So you should be looking at the positive Z scores. What value should you be looking for? 1.5. Okay, 1.5. So what value do you get for 1.5?
.9332.
0.9332. Is this correct? Anybody else got the same value?
Yes.
Okay, good.
Yes.
Good. Now, should it be the answer though?
No, you should subtract it by 1.
Subtract it from 1. Why?
Um,
You're correct.
because you have that remaining chunk, and what that 0.9332 is accounting for is everything to the left, but you want everything to the right of the curve.
Perfect. Thank you, Jerry. So when you look it up in the standard normal distribution table, so you looked up the value for Z equal to 1.5. It does not give you area to the right. It gives you all the area to the left of that point. Okay, all the area to the left of that point. So we really don't need the area to the left. We need the area to the right. We are looking for this area, not the area on the left. We don't want this area. How do I find it? Easy. You have to subtract from 1 the probability of Z less than 1.5. Remember, standard normal distribution table always give you the probability of z less than. It never gives you the greater than, but you can find the greater than probability, okay? It always gives you the probability less than, not the greater than. Okay, and why do I subtract it from 1? Because all the area under the curve must add up to 1. All the area under the curve must add up to 1. So from 1, if you subtract this left portion, okay, you'll be left with the right portion, what you need. So that means you'll be doing 1 minus 0.9332, which is 1 minus 0.9332, that is 0.0668, 0.0668. That's what it is. So probable, which is approximately 6.68%. Probability that someone makes more than $1,950 is about 6.68%. Now, next, I'm going to do another problem. Find the probability that someone makes less than, this time I'm making it less than $1,050. Okay. Again, we could use the same thing. So let me do a little bit of erasing here. Oops, I don't want to erase that. Okay, so I'll just leave it there. This time, what I'm gonna do is this. Less than 1,050. So let's do the z value calculation here. So z is equal to x minus mu over sigma. X is 1,050 minus mu is 1,500, okay? Divided by 300, right? So z is gonna be equal to negative 450 over 300, which is gonna give me z is equal to negative 1.5. So this time, so let me use a different color. We are looking for negative, so this is not negative, sorry. This is 1,050. We are looking for probability that someone makes less than 1,050 is gonna be to the left, everything to the left. And if we translate it into z value, that gives us z is equal to negative 1.5, okay? So that's what it is, all right? So this point maps to this point. So probability of x less than 1,050 is the same as probability of z less than negative 1.5. Okay, now this time, look, it is unlike the last time, it is negative. So everybody go ahead and look at the look at the table.
0.0668.
0.0668. Should we subtract it from 1? Yes or no?
No.
No. Because we are looking for the area to the left or less than. See, this is less than. Okay, when you have less than, you're looking for the area to the left. When you have greater than, you're looking for area to the right. So you don't have to subtract it. So that's your answer. So the probability that someone makes less than 1,050 is 6.68%. Now I want to bring to your attention here this thing. Look, because of symmetry, this is the same as this, isn't it? This area to the right is the same as area to the left, because This value is 1.5 standard deviations to the right. This value is 1.5 standard deviations to the left of the mean, right? So this shaded region should be the same as this shaded region. And that's why you get this value and this value the same. That's the symmetry part. Maijin, you were talking about the symmetry. Any bell-shaped curve, okay, is symmetric about the middle, about the mean, okay? So that's why. Now the next question I'm going to be asking is this. Find the probability that someone makes between 1050 and 1950. This should be very easy. I kind of structured the problem in such a way so that you guys don't have to do the calculation again. So we know that 1050, it maps to what? What z value does it map to?
The 0.0668.
That's not 0.0668 is not the z value. This is the z value. This is the probability associated with that z value. Okay. So 1050 goes into negative 1.5. So z negative 1.5 is less than z is less than 1950. It goes to what? 1.5. So 1.5. Now, what area is it representing? So let me just draw it here. So this is your 1.5. This is negative 1.5. So in between, meaning we are looking for this middle region. So here we are looking for this green shaded region. We are looking for this green shaded region. Okay, so finding the probability that someone makes between 1050 and 1950 is like finding this middle green shaded region. So which we can easily find. Okay, now if I want to find the middle region, I could do the following. Probability of z less than 1.5, okay, which means 1.5 is right here. Less than means it's going to give you everything to the left, but I don't want everything to the left. I don't want this black shaded region. I do not want it, okay? So then I just need to subtract it. So there's going to be probability of z less than negative 1.5. Remember, black shaded region, you find it by considering this z value, negative 1.5. Okay, that black shaded region you find by considering the negative 1.5 z value. And now you have everything that you need to do. For this one, you already found it 0.9332, 0.9332 minus, for this one, you also found it 0.0668. So 0.9332 minus 0.0668, which gives you 0.8664. That is 86.64%. So the probability that a randomly selected person makes between 1050 and $1,950 is about 86.64%. That's what it is. Are all these three examples clear to you, everybody?
Yes.
Do you feel that you need more? You need to see more of these types of examples?
I'm good.
Okay, I'm gonna continue, honestly. But before I continue, I want to give one more example of this type. This time I'm gonna kind of pick some random numbers. Find the probability, again with the same mu and sigma. Mu is 1500 and sigma is 300. Find the probability that someone makes between, I don't know, I'll just randomly pick two numbers. Someone makes between $1,700 and $2,000. Okay, and this is something different. The probability that someone makes between $1,700 and $2,000. So let's go ahead and create the diagrams. Your 1500 is right here. 1700 is gonna be right here, and 2000 is gonna be right here. Someone wants to make, someone falls between these two numbers. That means someone makes between $1,700 and $2,000 would be like finding the shaded region. Now look, this one is, both of these numbers are to the right. Even before I do the z-value calculation, can you tell me the sign of the z-value? Is it gonna be positive or negative or zero?
A positive number
Positive. Why positive?
because it's to the right and not the left.
Okay, perfect. That's exactly the reason. It's to the right of the mean. That's why it's gonna be positive. So we are gonna just go ahead and draw the standard normal distribution curve, which has a mu of 0 and sigma of 1. So we need to find these values. So let's go ahead and use it. Use this space. Z is equal to x minus mu over sigma. So x is 1700 minus mu is 1500 divided by 300. So Z is going to be 200 over 300. 2 zeros cancel out. That's 2 over 3, which is 0.67 roughly. It's 0.6666. So I'm going to do 0.67. So this is 0.67. So one value. So this maps to this. Now we are going to have to do the same thing for 2000, right? So Z is equal to x minus mu over sigma, which is 2000 minus 1500 divided by 300. So that's going to give me Z is equal to 500 over 300. This cancel out, that gives you 5 over 3, which is about 1.67. So that's 1.67. So that guy 2000 maps to 1.67. So we are looking for this strip of region. That means finding the probability is equivalent to finding the area. Remember, in the continuous case, finding the probability is equivalent to finding the area. Finding the probability is equivalent to finding the area. That's how we define it. So now probability that x falls between 1700 and 2000, or probability of 1700 less than x is less than, there should be less than sign here, less than 2000 is the same as probability of z falling between 0.67 is less than Z is less than 1.67, right? So now if you look it up from the table for 1.67 is going to give you all the area to the left of 1.67. But we don't want this unshaded region. We don't want it. How do I get? So if I write down probability of Z less than 1.67, I'm getting everything to the left of this vertical line, right? To the left of this vertical line. But I don't want everything. I don't want this unshaded region. How do I get rid of it? Look, that unshaded region is associated with this 0.67. See this 0.67? So if you look it up from the table for 0.67, probability of Z less than 0.67, then if you subtract, then you'll get rid of this unshaded region and you'll be left with the shaded region right here, which is exactly the same as this. Now I want everybody to look at it, okay, and give me the value. For Z is equal to 1.67, what value do you get? Z is equal to 1.67. I want not the usual people. I want other people to be proactive. So,
Professor, I have a question. So when you're looking for the Z value, when it's like a 1.67 and it's not like a perfect number, like you know
yeah,
how do you, I don't understand how you find that number.
you would go to 1.6 first, okay? And
Okay,
then
and
go along that row. And on the top, do you see 0.07 some column?
yeah.
Okay, so go along 1.6 row, and then when you see the column 0.07, you stop there, and whatever number is there, that's your number.
Okay, so it's gonna be 0.9525.
Is it 0.9525? Anybody else got it?
Yes.
Yes.
Okay. I want somebody else to tell me
Sorry.
for 0.67. Gloria Ortiz. Gloria Ortiz. Jonathan Martinez. Juan Perez.
Isn't it 0.7486?
Is it
Yes.
0.7486? Okay, good. Minus 0.7486. So 0.9525 minus 0.7486 is gonna be 0.2039. Okay, so which is about 20.39% chance. So the probability that someone makes between between 1700 and 2000 is about 20.39%. Is this okay, everybody?
Yes.
Yes.
Good. I will yet give another example. I want you to be really comfortable. I want you to be getting a good sense of this normal distribution and how to find probabilities, because this is very important. I'll give you not another. I'd actually give you. I'll spend the rest of the class working on this, so that you are completely solid on it. Now, I'm gonna give you this interesting example. Again, the numbers are the same. Probability that X is less than let's see, 1500. Okay. X is less than 1200. Okay. or X is greater than 1800. So this is an interesting one. Probability that X is less than 1200 or probability that X is greater than 1800. Now let's draw the bell-shaped curve. This is your 1500 and this is your 300. 1200 is here. 1800 is here. You want X to be less than 1200, which is what? Everything to the left. You want X to be greater than 1800, which means everything to the right. Are you following this?
Yes.
Now, I'm not going to do the Z calculation here. It's easy. You guys can see it. 0, 1. For 1200, what is the Z value? Can somebody just tell it to me? You don't even have to do the calculation. For 1200, what is the Z value? How many standard deviations are you moving to the left from the mean?
The Z value would be 1.
You're moving to the left, so it should be what?
-1.
-1. Because from 1500, if you take away 300, you get to 1200, right? You're moving to the left of the mean, so Z should be negative. Now, to get to 1800, how many standard deviations are you moving to the right?
A +1.
Exactly. That's it. That's done. On purpose, I made it easy so that you guys can. So we are looking for either this area or this area. So now this translates to probability of Z less than -1 or Z greater than 1. Probability of Z less than -1. So somebody find that value. So this, by the way, before I go there, or means what you have to add it. Probability of Z less than -1 plus probability of Z greater than +1. You have to add these two numbers because I want this area plus this area, which is equivalent to finding this area and this area, adding these two together. Now, probability of Z less than -1, which is very easy. What is it?
0.1587.
0.1587 plus probability of Z greater than 1. What is it going to be?
0.8413.
413.
0.8413. Is that correct?
Yes.
Are you sure?
Yeah, because me and the other gentleman said it.
That doesn't mean make it correct.
And we checked this.
Just because more people are saying it doesn't make it right. There are many things in this world. Many people say it's wrong.
We checked the chart though, Professor.
You're still wrong. Anybody knows why they're wrong?
Is it not supposed to be on +1?
Oh, it's because that number is to the left. We forgot to subtract it from 1.
Exactly. For positive one. See, just because many people are saying it doesn't make it right.
Okay, so you would do the 0.8413 minus 1?
1 minus
1
0.8.
minus, sorry.
Yeah. And what number would that be?
It will be 0.1587.
Uh-huh. Now you're talking 1587. Do you see that both of these numbers are the same?
Yeah, now I see it.
Why are they the same?
Because they're symmetrical.
Exactly, because they're symmetrical. Because you didn't have to do the calculation. You move one standard deviation to the left, and that's the value, 0.1587, right?
Mhm.
And you move one standard deviation to the right. So everything to the right is going to be a mirror image of everything to the left, right?
Yes.
So that should also be 0.1587. So using symmetry, you can do the calculation. So 0.1587 plus 0.1587 is 0.3174, or there is a 31.74% chance that a randomly selected person would make less than $1,200, or that person would make more than $1,800. Now, in the exam, if I gave you something like this, I might change the number from 1,200 to maybe 800, or 1,800 to 2,200, or something like that, right? Or change it from 1,200 to 1,400, and change it from 1,800 to 1,700. So you just need to be able to find it. Is this okay, everybody?
Yes.
Yes.
Oh,
Thank you.
okay, I think I covered everything that I could think of. So hopefully this should help you. Watch these videos multiple times. I don't know about you guys. I'm no genius. I'm like ordinary person like everybody else. When I learned it as a student, I struggled with it. It took me a lot of time to get the concept. I did very well as a student. In freshman year in college, I took this class, and I got really, I struggled at the beginning, statistics, but then at the end, I did very well in the class. Actually, I think I was the only one who got A+ in the class, even though there was not A+. The professor said, okay, you'll get an A+. You have done very well, but there is no A+, so I can give you an A+. But then many years, so I was happy. Then many years later, when I started to teach, that's when I realized, oh my goodness, even though I did so well in this class as a student, when I started to teach, I realized that how much I did not know versus how much I did know. There is so much that I didn't know, because the clarity and understanding, it doesn't come from just taking the class quickly in a semester and being done with it. It really comes, if you really want to be good at something, you teach it to somebody else. That's when you'll see how much you don't know. That's when all the confusions and the clarifications are going to show up. So even though it's a virtual class, online class, if possible, pair up with other people, work together, explain it to somebody else, okay? When I started teaching, that's when I really started to get the true feeling and understanding of these topics. And I don't expect you to get it in a semester right away when I'm going through all these things very quickly. However, what I would request you is that you look at these examples multiple times. Keep trying, keep looking at it, keep looking at it, keep looking at it, okay? And at the end of the tunnel, there is light, okay? So at the end of the semester, you'll not only do well, but you'll get a better understanding. Then when you go into real world, you will be using statistics, but to what level, that's questionable. If you go into research, then you will probably be using most of the things I'm talking about. But if you go and have any other jobs, you'll probably be using the basic stuff, okay? Normal basic statistics, okay? And probability too. All right, so that's where I will stop for this one. Now, I kind of wanted to give you a couple more examples before I let you go for the day. So I did these problems, but I'm gonna do them here again. That should end this section. And then in the next class, we will start sampling distribution. That's another exciting topic. It's fun, okay? You might think that I'm crazy, that I'm calling it fun, but it is really fun. Statistics is useful. Trust me on that. Statistics probability is useful. Many of you don't realize it. I tell you, everybody loves self-driving cars nowadays, okay? When you are a self-driving car, by the way, it doesn't run by itself without any math behind it, okay? There is a lot of application of probability and statistics, okay? In self-driving car, because it is using something called artificial intelligence. Artificial intelligence has a lot of probability and statistics built into it. So when you are driving a car, you love to drive a car that drives itself, but the engineer who designed it, if he or she didn't do the probability and statistics properly, you might be in trouble, okay? There are so many things. Actually, this reminds me of something very interesting. You guys are too young to remember that. I was little at that time too, not too little, old enough to understand things. Back in 1987, okay? There was a space shuttle that crashed. It was called Challenger, and I still remember it was all over the world in news. Challenger disaster. I think it was in 87. Yeah, it is is it 87 or 85? I think 87. And it exploded in the space. So then at the end, I think they came up with the explanation or reason for explosion, because there was some metal that put into the space shuttle that expanded and shrunk based on temperature, and they didn't do proper statistical analysis on that. I think I may have even seen a video on it on YouTube or somewhere. So you can see how important this topic is. And nowadays, our society, our economy is very data-driven. Everybody must have some basic knowledge of statistics that will help you do your things properly. If you work for a business, you have to understand the numbers. You have to understand the trends. You have to do regression analysis. If you're analyzing data points, like if you go to Target, you guys don't care about statistics, but you just go there and buy something. But people, those who run Target, they're doing a lot of statistics to understand customer behavior. They're doing a lot of statistics to analyze customer behavior, purchase behavior. Things are very complicated nowadays. It could be in terms of doing sales and marketing. Like one of the very simple things that people are doing as you walk into a store and you're moving around, they are tracking through video which aisle you are going to, or they are tracking your cell phone even. They are finding your position and trying to see where you are going to. And based on those kind of analysis, they make decisions on how to sell products and services to you. There are so many interesting stuff happening with AI and data analysis and statistics. So anyway, enough of that. I'm just trying to give you a sense of how broad this topic is and how useful it is. So here is one problem I made up. The lifetime of a smartphone is normally distributed. So keyword, normally distributed, with average usable time approximately 36 months, which is roughly about kind of good number, like 3 years. And the standard deviation is 6 months. If you want to purchase an insurance policy so that 2% chance that your phone will not be fixed, there is a 2% chance that your phone will not be fixed, okay? If it is broken, what should be the length of time for which you should buy the warranty? So the lifetime, is normally distributed, okay? With a mean of 36, standard deviation of 6 months. You buy a smartphone, be it iPhone or some other phone. You buy an iPhone, so let's say you want to make sure that there is 2% chance that it will not be fixed, but 98% chance that it will be fixed. All right? So what you would want to do, you want to make sure that you buy long enough insurance so that the phone is fixed. That means 98% of the times it would be fixed. So you have to go up to a certain point here where if your phone survives up to that point, it will be among the 98th percentile, meaning 98% or less of the phones will survive. Okay, so I don't know if I worded it properly. So this is kind of a concept. Is slightly difficult to explain for the first time. If you're looking at it, it might get a bit confusing. 2% chance that it will not be fixed. So if your phone's life is among the top 2% right here, so this is 0.02 or top 2%, then they will not fix it. Otherwise, they will fix it. So the probability of your phone surviving long enough to be among the top 2%, if that happens, that means if you fall among the top 2%, your phone will not be fixed. But others, in other situation, 98% of the times it will be fixed. And this is the point I'm looking for, X. Now, I know the top areas. I'm gonna go into the standard normal distribution table, 0 and 1. 2% chance that it's not gonna be fixed. So you're gonna have to be among the top 2% for not to be fixed. So this 0.02. Now, if you look it up in the table for an area of 0.02, what do you get? Can you find it and tell me? Area of 0.02, what do you get for Z value? Quickly, please give it to me, the answer.
Is it 0.5080?
You're looking at the wrong thing.
Okay.
0.02 is not the Z score, is the area. So you should be looking in the area inside the table.
Am I supposed to be looking at the negative chart?
Good question. You find it out. I won't tell you. Anybody else? Quickly. The answer is there on the screen. You probably haven't realized it. If you look for area of 0.02, it's less than 0.5. So it should be in the negative Z. But you should technically not be looking at 0.02. Why? Because 0.2 is the area to the right. You should be looking at area to the left, right? Because normal distribution, standard normal distribution table is cumulative from the left. That means it gives you area to the left. So you should be looking at 0.98. But even after that, if you look at 0.02, you will get negative 2.05. that means you're looking at the left, but you're looking for the right. By symmetry, it should be 2.05. By symmetry, it should be 2.05. So this Z is representing 2.05. And corresponding to this Z, there should be an X value. So my Z is equal to X minus mu over sigma. Z is 2.05. X is the number that I'm looking for. Mu is 36. Sigma is 6. Then I multiply both sides by 6. And that gives me 12.3 on the left. And on the right, X minus 36. If I do the math, I get X equal to 48.3 months, or roughly about 4 years. So you have to purchase insurance for 4 years to ensure that 98% of the times your phone will be fixed. By the way, Apple sells you insurance for 2 years at the most. Did you know that? And they sell you, how much is the Apple insurance? I think I pay $199 or something for my iPad, and $99 for my iPhone. And they will not fix your phone more than twice. Okay, so if you buy the insurance for, let's say, 2 years, they will replace it at most up to 2 times if it goes wrong, or if something happens to it. This is actually kind of free money for them. Not free money, but pretty profitable business for them, I should say that. It's profitable business because if you look at the life expectancy of a phone, first 2 years, nothing is going to happen probably. In reality, average life expectancy is probably a little bit more than 36 months, maybe 4 years. I kind of wanted to keep the numbers nice and pretty. That's why I designed it that way, this problem. But in reality, you could probably use a smartphone. No, maybe not 4 years, maybe 3 years, maybe somewhere between 3 and 4 years. Like I have iPhone right now, which is a little over 2 years old. Nothing has happened. Nothing has happened, but my insurance is gone. So for the most part, they make money. They do the mathematical calculation or probabilistic calculations before they sell the insurance, because they don't want to lose money, right? So there is math behind things that you don't think about. Like when you buy an insurance, you think, oh, okay, my phone is safe. You don't think about the math that goes behind it. There is mathematical analysis that's being done before they offer you this insurance policy. By the way, that brings up another question: expected value problems. All the insurance companies, doesn't matter what type of insurance companies, they must have to do expected value calculations. Otherwise, they won't be able to sustain in the business. If it is not profitable, if their premium is too low, that they won't be in the business. They will not make money. So they have to do probabilistic and expected value calculations so that they can be profitable. The same thing with casinos. They do those kind of calculations to make sure that they are profitable. When you're playing slot machine, of course, casinos buy them, right? So the people, those who are designing slot machine, they design it in such a way that odds are against you, not in favor of you. Next, so there is another example like this. Now, the next problem is the grade point average of students at your school is normally distributed with 3.2 mean and standard deviation 0.25. Your institution decides to give scholarships to students who have GPAs among the top 3% of the students. So now this time is among the top 3%. If you're among the top 3%, you will get to apply for scholarship. So this is top 3% means 0.03. So you're looking for this X value. Now we are going to go to the standard normal distribution. Okay, this has a mean of 3.2, standard deviation sigma of 0.25, right? And this area is 0.03. So we are going to find the corresponding area 0.03. So this is 0.03. And we need to find this Z value associated with 0.03, which is 1.88. 1.88. So if you look at 0.03 in the standard normal distribution table, you might get negative 1.88. Okay, you should technically be looking for 0.97, which is 1 minus 0.03. But if you get negative, that means you're getting the left value. You'll get negative 1.88 because the left side is also going to be 0.03. So if you're looking for 0.03, you're finding this value, this Z value. But you're looking for the mirror image of the Z value, which is positive 1.88. Now, I put it here for Z value. X is something I'm looking for, and 3.2 is the mean, and 2.25 is the standard deviation. Then I multiply both sides by 0.25. That gives me 0.47 on the left, and on the right, just the numerator, x minus 3.2. And if I do the math, 3.67. So if someone has a GPA of 3.67, that person would be among the top 3% of the GPA. Okay, that person's GPA would be among the top 3%. So if you announce a scholarship, you'd say, okay, if your GPA is 3.6567% or above, you can apply for the scholarship. Okay, you can apply for the scholarship if your GPA is 3.67 or above. That will put you among the top 3% of the students. Now, what I could do, I could ask you in the exam, hey, we'll give scholarship to top 5% of the, we'll let students apply for the scholarship if they're among the top 5%. Then in that case, you just have to do 0.05, this one. And this is a very standard number, which is negative. In this case, it's going to be 1.96. Is it 1.96? Can somebody check it? Oh no, it's 1.645, sorry. For 0.05, it's 1.645. So I might change this number from 3% to 5%, right? Or 3% to 10% or 7. And that's about it. I might change the GPA from 3.2 to maybe 3.5 and standard deviation, leave it at 0.25 or something like that. Or I can't leave it at 0.25. I have to reduce the standard deviation because it won't go beyond. GPA goes no more than 4, right? So that's what it is. Any question, anybody? Is it okay, everyone? Everybody okay? All right. Now, that kind of concludes the normal distribution and finding the probabilities associated with normal distribution. That kind of ends this section, okay? And I gave you a practice problem here. You can look at it, similar. I put this value 15.87%. Does anybody know why I put it? This is a special value, 0.1587. What should be your Z-score here? Can you tell me? Without doing it, without even looking at it, you should be able to tell it. We dealt with that number before. Z should be equal to
1.88.
No, 1. Remember, when you are given percentage, you are given the area. You're not given the z-score. You're finding the z-score. There are two things. If you look at the table, okay, let me clarify this thing. This is very important. See, there are two things given here. One is z value. See, if I gave you z value of 1.67 or 1.57, let's say, you look at 1.5. So let's make it negative since I'm on the negative page. Negative 1.5, which is right here, then 7.07, which is this column, okay? So you go along this row, and this is 0.07 column, right? And you come right here, so 0.0582. So z for z value, so probability of z less than negative 1.57 is gonna be 0.0582. This is one way of finding values. But another way of finding value is that you are not given z value, you are given one of the probability values from the table. Like when I say 3%, in essence, that is 0.03. So you have to look here and get the value that is closest to 0.03. So look at this 0.03. Let's say we are looking for 3% or 0.03. So 0.03, which is less than 0.5, means it's going to be in the negative value. 0.03, 0.03. Let's see, 0.1 here. No, 0.02 I see here. 0.03 I see here. So look, the closest value we get to 0.03 is 0.0301. And where does it fall? Look here, negative 1.8, and look here, 0.08. So that's how you get it, negative 1.88. You should be able to find these values. Now let's go ahead and give you another example. Let's say I gave you 15.87%, which is 0.1587. This is not a z value. This is not z, okay? This is probability. So 0.1587, which is very standard value, which is right here, 0.1587. Negative 1.0 and the 0 column, so negative 1.00. If I gave you, so let's give you another example for, let's say, 57% or 0.57. So this is greater than 0.5. So 0.5, so 0.50 here, 0.57, we are looking for 0.5759, I see here, 0.58, 5793, 5714, 577, sorry, 5675, 5753. So this is the closest value I get, 0.5714, and that corresponds to 0.1 and 0.08, so it's 0.18. So z is equal to 0.18. So probability of z less than or equal to 0.18 is gonna be 0.5714. And that is how you will be finding the z-score. So there are two things happening here. One is given, I talked about it before, z is equal to a, find probability of z less than or equal to a, which is some value, some number, let's call it p, okay? No, not p, p is not a good symbol to use. Let's call it some value c, okay? This is one. Now given c, that means this time you're given the probability, actual probability, okay? Given c, which is probability, find the corresponding Z value. Okay, so for this one, you'll be looking at the first column and looking at the top row. Okay, then you find the probability. For this one, look inside the table. Look inside the table. Okay, look inside the table. That's what it is.
I have a question.
Yes.
So when you're having to look inside the table for a number and it's not always the exact number, how do you know which one to go to? So like the one
The
that you just,
closest value. The
so what
closest
if the, like example, what if the 0.5714, what if that one was a 9? Do I disregard that altogether? Or if that was like a 9, would I go to the next one lower?
lower.
You would go to
If
the
you-
lower one.
Yeah, so if you had 0.571 instead of this, if you have 5794, then you try to get as close to 0.57 as possible. Okay, that's the rule. There is no hard and fast rule here. I just try to stay as close as possible. Some people take two values that are close to each other, then they average them or whatnot, but I don't do that. Just I stick to the simplest solution. Simple, closest value that you can get to, that's the value you should be looking for.
Okay, thanks.
Mhm. All right, guys, that's pretty much it for the day. So next time, I put some homework online. I'll put some more online. It's not going to be due until after the spring break. I'll just put it. You don't have to do it, okay? But if you are not going anywhere for spring break, maybe you can just look at them to get a head start, okay? So next time we're going to be talking about sampling distribution. So I'll put some problems on sampling distribution, and if you have time, just browse through it. This is a bit of a difficult concept. So look through these examples up until confidence interval, okay? So look through these examples if you have time, and stay safe and stay healthy. Times are very difficult right now. So don't travel unless you have to, okay? And do social distancing, stay safe, wear mask. Spring break is a time when younger people go out and mingle with others, and peak time or prime time for spreading the coronavirus. So please stay safe, stay healthy, take care of your families, okay? Help them, don't be a risk to them by going out and hanging out with people too much. Wear mask, use hand sanitizers, and avoid people, crowded places, and do social distancing. All right, thank you, and have a safe and healthy spring break. I'll speak to you guys on Monday, the 29th. Okay, thank you very much.
Thank you, bye.
Thank you.
Bye, thank you.